Welcome to the lecture on the topic Physical and Chemical Adsorption. I am Dr. P. Bhanuprakash, working as lecturer in chemistry in PVKN Government College, Autonomous, Chittoor. Learning outcomes. Through this lecture, we are going to discuss about the following subtopics: adsorption, absorption, types of adsorption, that is physical adsorption and chemical adsorption, and finally about the differences between physical adsorption and chemical adsorption. What is adsorption? The process of accumulation, or we can say the concentration of molecules of a substance more on the surface of other substance than in its bulk portion is called adsorption. From this picture, you can clearly see that these are the gas molecules adsorbing on the solid surface of other substances. Here the complete gas molecules are accumulating more on the surface but not deep into the bulk. Hence it is termed as adsorption. Let us understand what is adsorbate and what is adsorbent. The substance which is accumulated on the surface of other substance is called adsorbate, and the substance which provides the surface for adsorption is known as adsorbent. In this picture, the gas molecules are considered to be adsorbate because they are accumulating on the surface of the metal surface, and the metal surface is known as, or we can say it is termed as, adsorbent. Let us see few more examples for adsorbate and adsorbent. If you consider gases like oxygen, hydrogen, ammonia or sulfur dioxide in a closed vessel containing powdered charcoal. After some time, you can observe that the pressure of the gas in the vessel decreases. This is because the gas molecules like oxygen, hydrogen, ammonia or sulfur dioxide are adsorbed at the surface of the charcoal powder. Hence, the gases are called adsorbate and charcoal is known as adsorbent. Similarly, in the adsorption of oxygen gas on tungsten or hydrogen gas on nickel, the metal acts as adsorbent. The silica gel shown in this picture is a best example for adsorbent. The wet air becomes dry in the presence of silica gel because the water molecules get adsorbed on the surface of the silica gel. Here the water molecules are considered to be adsorbate and the silica gel is considered to be adsorbent as it provides surface for the adsorption. Adsorption is a surface phenomenon. It depends upon the surface area of adsorbent at the given temperature and pressure. Greater the surface area of adsorbent, greater will be the adsorption. Particularly, the finely divided powders of solids acts as good adsorbents due to its large surface area. Let us see the few examples for adsorbents: charcoal, clay powder, silica gel, alumina gel, finely divided metal powder. For example, you can see in this picture iron powder. They all act as good adsorbents due to their large surface area. Adsorption is an exothermic process and it increases with decrease in temperature. We all know that in exothermic process, heat energy is released. Therefore, the change in enthalpy delta H of adsorption is always negative. In adsorption, the freedom of movement of molecules is restricted. Therefore, the entropy decreases. Thermodynamically, the change in entropy delta S is negative. Let us discuss about the differences between adsorption and absorption. In absorption, the substance penetrates deep into the bulk of the other substance and distributed uniformly, whereas in adsorption, the substance remains only on the surface of the adsorbent. From this picture, you can see the absorption of water by sponge. Here, water molecules enters deep into the, we can say, the bulk of the sponge material, and the water molecules are distributed uniformly. Water vapors are adsorbed by anhydrous calcium chloride CaCl2 but adsorbed by silica gel, which means that water vapors are penetrated deep into the molecular surface of anhydrous calcium chloride, but the water vapors stay on the surface of the silica gel. Let us discuss about types of adsorption. The adsorption of gases on solids is broadly classified into two types. Number one, physical adsorption, which is also known as physisorption. Number two, chemical adsorption, which is also known as chemisorption. Then, what is physical adsorption? If the accumulation of gas molecules on the solid surface occurs on the account of very weak van der Waals forces, then that type of adsorption is known as physical adsorption. Or in simple, we can say if the forces of attraction between the adsorbent and adsorbent is weak van der Waals forces, then that adsorption is termed as physical adsorption. If the gas molecules are held to the solid surface of adsorbent through some chemical bonds like covalent bond or ionic bond, then that type of adsorption is known as chemical adsorption or chemisorption. Let us discuss in detail about the differences between the physical adsorption and the chemical adsorption. In physical adsorption, as discussed earlier, the forces of attraction between adsorbate and adsorbent molecules are very weak van der Waals forces, but there won't be any true chemical bonds like ionic bond or covalent bond. In chemical adsorption, the chemical bonds like ionic bond or covalent bond are formed between the adsorbate and adsorbent molecules. Physical adsorption is reversible. Chemical adsorption is irreversible. Physical adsorption is not specific in nature, which means adsorbent does not show any preference for a particular gas, whereas the chemical adsorption is highly specific in nature, which means that this chemical adsorption occurs only if there is some chance of formation of chemical bond between the adsorbate and adsorbent. The enthalpy of adsorption is very low in physical adsorption, whereas the enthalpy of chemical adsorption is very high. This is because in physical adsorption, very weak van der Waals forces exist between the adsorbate and adsorbent. But here, a true chemical bond formation exists between adsorbate and adsorbent in chemical adsorption. Hence, it releases good amount of heat energy. Physical adsorption increases with increase in surface area of the adsorbent. Chemical absorption, or we can say chemisorption, also increases with increase in surface area of the adsorbent. Greater the surface area, greater will be the physisorption as well as chemisorption. Physical adsorption decreases with increase in temperature, whereas the chemical adsorption first increases with increase in temperature and then decreases with an increase in temperature. Let us understand the effect of pressure on physical adsorption and chemical adsorption. Physical adsorption increases with increase in pressure. Chemical adsorption increases with an increase in pressure, but at high pressures it is independent of pressure. In physical adsorption, the absorption takes place in multimolecular layers on an adsorbent surface under high pressure. In chemical adsorption, adsorption occurs in unimolecular layer. Physical adsorption requires no activation energy, but in chemical adsorption it utilizes activation energy to form activation complex during the adsorption process. Physical adsorption is an instantaneous process, but the chemical adsorption is very slow process due to the formation of chemical bonds between the adsorbate and adsorbent. Thank you very much.